This is just one of the main threats for today. In addition to, excuse me, in addition to possible derecho, a likely derecho up here in the upper Midwest today. So first, I'm gonna talk briefly about the current hazards here. So we have heat advisory over the good portion of the deep south. Um, extreme heat warnings dotted throughout the wherever the heat advisory is. Extreme heat watches in different areas adjacent to those extreme heat warnings. Heat advisory ongoing up here in the northeast quarter. Some different flood warnings going on. Flood watches in New Mexico. A few red flag warnings, but the majority you see here is based on heat today. So here is the composite radar for the United States. We have a couple different MCS type systems moving through the flow right now. One in the the Montana parts of North Dakota on the Canadian border. One in Ontario, and one moving through Iowa and Illinois, parts of Wisconsin, prompting some flood concerns in these areas. They're moving pretty slowly right now. So for today, with severe weather, we're going to have another MCS move through the flow here. I'm going to show you what the SPC has outlined here. We have, for categorical, a moderate risk already, categorically, for today. Bullseye in South Dakota, most of central eastern South Dakota, parts of western Minnesota, with a enhanced risk surrounding it, and then a slight risk surrounding it, which a large bullseye here. And this is mostly driven by wind. You can see 40% wind risk, actually 45. Surrounded by 30%, 15%, 5%. And a 10% significant wind risk means 10% chance of significant winds, which is 60 knots or greater, within 25 miles of a point, anywhere in the hatched area here. The SPC used some pretty strong wording with the derecho likely moving through the area today, with significant winds, maybe up to 100 miles an hour today. There is a hail threat as well, not nearly as high, 15%. Although if you have hail mixed in with high winds, that can really be a serious problem, as you can imagine. Oops. Tornado risk is 5% in the bullseye here, same general area where the ratio is supposed to go through, with a larger 2% risk surrounding it. Now, what's going to happen is pretty quickly there's going to be storms develop quickly, meaning while not a lot of this discrete activity is forecast, but within the line, boat echo segments within the line can produce pretty strong tornadoes, given the Storm relative helicity values exceeding 300 meters squared per second squared. Low level shear with those kind of numbers has a chance of producing strong tornadoes. They don't have a hatch risk here right now, given the straight line wind environment. The hodographs aren't going to be that curved. By hodographs, I mean shows the change in direction with height with winds. And if you have large elongated hodographs with curvature, you have a better chance of stronger tornadoes. And in this case, it's more of a straight line wind threat. But if you have segments within the line that's moving through here, say a line moving this way, and you have those segments that bow out. I can't really draw that closely with that, but you get the idea. Triangulation speed to the east, some rotation or convergence gets on the line, and quick spin-off tornadoes are very possible. Not likely, but possible. So what I'm going to do next is go over the future radar timing for the severe threat up here in this area today. What's driving this severe threat today? Well, as you can see over in the southern Minnesota, they have a short wave moving through the flow right now, which is fueling the ongoing convection. They move through time here. I'm going to move this through kind of slowly. Enhanced flow. Moving through enhanced winds moving through the flow with embedded little short waves in the flow. What happens later in the day today, you have some deepening and some real short wave, just enough energy and dip, vorticity, and given the very unstable environment with the high moisture and heat, leads to increased convection. You see the lower level heights here where you have a kind of a kink in the flow, which you can see the enhanced winds along this at 700 millibars, which is, of course, maybe about, I don't know, um, midway between 850 and 700. So it's really, this is where you can really get an idea of a short wave in the flow. And with these kinks in the flow, this really gives a chance for convection to fire. And this is apparent. This is the high resolution rapid refresh model. I'll move this through time here. And these black areas are where model thinks there'll be stronger updraft helicity values, which is greater than 75. I really don't know exactly. It's greater than 75 meters squared per second square. So that should be enough. Updraft helicity values. That's a parameter they use to help determine if you're going to get supercells and possibly tornadoes. So whatever the black areas are denotes the highest above 75 meters squared per second square values. So you move through the flow here, you have some discrete cells that form. I have a feeling that these are probably going to be initially hail producers. And if we take a look at the sounding real quickly, was just not a good. That's kind of yeah. So yeah, some curvature. What you're looking for here is a little more in the weeds, but I wanted to explain it anyway. Some curvature in the low levels with mostly straight photographs. Otherwise, just gives you an idea of, first of all, if the photograph was, say, curved like this, say, I got a different color here, going like this, or going even further up like this, you have really the potential for really significant tornadoes. Uh, and CAPE is just simply your energy in the atmosphere. So there's plenty of that, which is the right there, 3,200. Right? This may be a little bit underdone, may not. We'll just have to see. You can see another thing you look for. Well, this is your 0 to 3 kilometer storm velocity values, which are exceeding 300 meters squared per second squared, which has potential for a moderate potential for severe weather. Another thing you look for is 3 CAPE, which is your lowest CAPE in the atmosphere down here, 0 to 3 kilometers, like right about there. 58, which is in the moderate threat range, and then decape and lapse rates. The decape over 1,000 means you have a higher than normal chance for downdraft cape. So with steep left rates creates a lot of lift in the atmosphere, and when the moisture comes back down, um, range into let's just say range into and gain speed. Excuse me. And as that happens, more low downdrafts can produce higher winds. And the higher the decape number, which indicates more dry air aloft. It's there's a lot of things that go into it, but the higher the decape values, say you get to 1,500 or something, you have a really good chance of having, if you get storms, of having downdraft winds that are excessive. One other thing you look at is lapse rates. Very steep lapse rates here throughout the whole column, really. Anything above 6 C per kilometer is dry adiabatic, which means the parcel is lighter than its environment, so it tends to rise a lot easier, let's just say, without forcing. So if it's below 6 C per kilometer, then that's the wet adiabatic, and it requires some kind of forcing, like orographic forcing at front or something like that. Another thing you look at too is a little free convection and LCL are right next to each other and relatively low to the ground, about 1 kilometer up. When LC and L level of free convection, LCL, are co-located and low to the ground. Let's just say you have a, let's see, condensation level, where the level where the air would condense in the clouds. And let's just say the parcel has to be lifted way up here for the level of free convection. Big distance between the two. Chance of storms are not that great. But since they're co-located, the parcel doesn't have to, once it reaches the lifted condensation level, it can immediately start rising on its own. Extreme buoyancy. Storms don't have to work very hard to produce storms. Allows a parcel to keep lifting on its own. And with a large space between the temperature and parcel here, a lot of energy to work with. And if we go back in time, I'm going to go back in time on the photograph here a little bit and see if there's a cap in place. Back to 1. A cap simply refers to a little warm air in the mid-levels, which inhibits convection, which you can see even before, see the temperature profile, low levels, it's over the parcel. So and the LCL and the LFC are apart from each other. So beginning of this, and it's quite dry at most of the levels except for the low levels. Move forward in time. The cap is already starting to erode. Not quite, but almost. And then as temperatures, you can see there's some SIN, which is SIN H is your convective inhibition. And if you, and it sounds counterintuitive, but if you want to have severe weather or like strong tornadoes or things like that, you don't want the cap to be broken too early. You want some dry air at the mid levels. That's what we have here. So the cap is starting to break. You see this 0 to 3 kilometer storm relative velocity values are quite strong. Let's go back one. This is some noise. It's when you have convection and ongoing storms is part of the analysis. It shows up in here, and it kind of messes with the photograph and different things. SQT they call it. So anyway, you can see the potential here for significant hail, tornadoes, and high winds, even to the west of where our threat area is. I'm going to go back here and go through time. You can see how it goes upscale into a line. I'm going to take another sounding here. Hour 17. Yikes. This makes me very nervous. This is scary. Okay. If this comes to pass, we are talking PDS tornado chances. I sure hope this doesn't come to pass, but this is pretty extreme. You see the photograph curvature? here at the low levels. Remember I talked about that? PDS tornado simply means very strong tornado, particularly dangerous situation, and the models are picking up on the fact that this could occur, and they're basing it off of photographs, low level storm velocity over 507 meters squared per second squared. D Cape 1259. 3 Cape is within the moderate threat range. The supercell parameters are off the charts here. EF4 plus. Oh Lord, this is incredible. I wasn't expecting to see this. Sorry, y'all. You see how the convection messes with everything after that. Even before that, you have Cape. I mean, this is the Cape of 5,000 is just extreme. That's just the energy in the atmosphere, and the 3 Cape is 100 right before that. So, anyway, um, it really, as a weather forecaster and a weather, meteorologist, I don't know everything and I can't predict how everything's going to come about, but I try to convey the weather the best way possible without hyping it up. Um, but when I see these kind of things, it's very sobering and humbling to think what the atmosphere can do. Although I think the biggest threat is going to be high winds. The fact that this is highlighting a possible PDS tornado within that area um, really makes me hope it doesn't come about, at least for tornado wise. What I'd like to do now is go through what it thinks the wind gusts are going to be. Models 60, 70 miles an hour. These models don't typically do that great showing exactly the highest winds, but you can see what we're talking about here: 60, possibly up to 90 miles an hour within the line here. So no wonder the SPC Storm Prediction Center has highlighted this area as with a moderate risk. I I wouldn't be surprised if they upgrade to a high risk today. But that it remains to be seen. Confidence seems pretty high this event will unfold. However, location is still a little bit, and initiation is still a little bit in question, like exactly where it's going to set up. But overall, looks like it's very likely to have, at the very least, severe winds moving through, possibly up to 100 miles an hour through the flow. So, if you're in this area here, pay attention to what's going on and follow the weather, your local weather stations, and people that go live like Max Velocity or Ryan Hall, and keep your eye to the sky. Don't go outside and try to take pictures of this stuff. You need to make sure you're in an interior building, interior of your whatever building you're in. If it's your house, some kind of interior closet with no windows, things like that. If you have a plan in place, and if you're at work, same thing. Just make sure you have a plan in place. And if you have a weather radio, turn it on. Anyway, I know there's other things going on with the weather today, including heat. So I'm going to go over that real quick, and that'll be it for today. For the temperatures, I showed this heat risk map every day this week. I'm going to keep doing so till the threat kind of never goes really goes away, does it, for the south, but as it wanes a little bit. So today you can see magenta, red, a good portion of the country. I showed you the hazards earlier, and it shifts eastward. Magenta kind of gets pushed south. Wow, look at that! Along the Gulf Coast is the only place where you really have a big risk for heat. In the desert southwest, a good portion of the country by the 3rd of August will be minor risk, 268.1 million, with a very small amount in Florida, extreme risk. So what does that look for as far as temperatures? These are max temps going through time here. See over time the temps cool off quite a bit. 70s. With heat building out west again, as I've been showing, Texas is really going to get in on the heat in the coming days. This is out through the 8th of August. So the extreme heat really is going to be pushed to the south, and then a high pressure system is going to build in the center of the country with not the extreme heat staying there for quite a while. Not like the it's gonna get they're gonna get much of a break. It's gonna go all the way up into the high plains towards the end of the week. I mean, end of the period here. This is the 12th, which is almost 2 weeks away. Excuse me. So, um, good news for the Northeast, Mid Atlantic, and South. Bad news in the long range for the middle part of the country. Oh, the upper Midwest won't be too bad, but in the high plains. But anybody in Texas area is going to be sweltering along with in the desert Southwest and the California desert here as well, right along the mountain range there. So anyway, that's it for today, folks. I spent a lot of time on severe weather because I thought it was so important. Stay safe out there, and have a great day.